Right. Well, in this class, let us discuss about the properties of determinants. As a first property, the value of a determinant remains unchanged if its rows and columns are interchanged. So when we interchange the rows and columns, there is no change in the value of the determinant. Let us prove this with an example. Verify the property 1. This is the property 1. What is that property? By interchanging the rows and columns, the value of the determinant is not going to be changed. Okay, it remains unchanged. So that is the one we are going to prove. Verify the property 1, that is for the determinant 2 minus 3, 5, 6, 0, 4, 1, 5 minus 7. So I have the determinant with the first row 2 minus 3, 5, 6, 0, 4, 1, 5 minus 7. Now let us expand. So what we do, we take the first element, is it not? And as I already mentioned, we have to ignore the first row and the first column since I have taken A11. Okay, so I had to consider only this. Do you understand? Right. So based on that, 2 into 0, 4, 5, 7, and then minus. So as we already know, that is, if it is a 1 1, it is plus in 3 by 3 order. If it is a odd number, then it is minus, then plus. Okay, it is based on what? 1 1, A 1 1, A 1 2, A 1 3. So it is a simple symbolic representation. So 1 plus 1 2 means minus 1 whole squared, that will result plus. Is it not? So every time we have to multiply by minus here. Is it not? And 1 plus 2 3. So minus 1 whole power 3 means that results minus. So it means the sum of these subscripts, when it is an odd number, it becomes minus, even number, this is plus. So this is the logic we are applied. What about the second one? The second one is A row 2, first column. So 2 plus 1, so 3. So it is odd number. So we can put minus. Then definitely it should be plus. And what about this? Minus. Okay. And the third one, that is A, what is that? 3, third row, first column. So plus 3 plus 1, 4. Is it not? So minus 1 power 4 means plus. So I can put plus, minus, plus. So you can by heart this symbolic representation. Okay. Right. Now, so let us come back. So 2 into 0, 4, 5 minus 7. Then I am selecting minus because minus here. Then I can take minus. In that case, I have to ignore this first row, second column. So I have to consider only 6, 1 and 4, 7. So that is why it is 6, 4, 1 minus 7. 6, 4, 1 minus 7. Got it? And let us move to the third one, that is 5. Okay, so take 5 outside. So now I should not consider the third column. Why? Because I had taken 5, that is the third element. Now I have to consider only this, is it not? So I have taken 6, 0, 1, 5. And the remaining thing you know. Okay, so we are able to get minus 28. This is clear? Right. Now let us interchange, okay, row and column. See, the first row has been changed. Now listen, let me identify by highlight. This is the first column. Now the first column has been changed as row here. Is it not? So rows and columns are interchanged. Do you understand? And here This is the second one. I change this into second row. And then this is the third column that has been changed into what? The third one. Let me use a different color so that it will be nice for you. Okay, right. So this is the third one, third column. Okay, now I am converting this. If I use red, everything goes. Okay, right. Anyway, now I have interchanged. Once again, I do the same exercise of expanding. Okay, now we are able to find out the solution that results the same answer, minus 28. So it means by interchanging row and column, the determinant's value remains unchanged. Okay, so the property 1 is verified. Do you understand this? Good. Let us move to the second property of determinant. If any two rows or columns of a determinant are interchanged. So in the previous case, that is, we discussed about the entire rows and columns are totally interchanged. Now let us select any two rows. Okay, so any two rows, note this point, any two rows or two columns of a determinants are interchanged. What happens? The sign changes. The sign of the determinant changes. Now let us test this property. Okay, right. Let me take this example. Determinant 2 minus 3, 5, 6, 0, 4, 1, 5 minus 7, a 3 by 3 order determinant. Now let us change row 2. Okay, row 2 means that is 604. So I have taken this 604. Okay, I have interchanged. Okay, so 604 I have brought it to the third row, and third row has been interchanged to second row. So it is the interchange between row 2 and 3 that can be represented like this with a double-headed arrow. So row 2 interchanged with the row 3. Double-headed arrow indicates the interchange of row 2 and row 3. Do you understand? So it has come here and this one has gone there. Okay, so row 2 and row 3. This is row 2, this is row 3. Okay, R2, R3. Now they have been interchanged. Do you understand? And let me consider this as that is determinant 1. Okay, so 2 minus 3 that remains same. This part has alone be changed. Okay, right. Now let us move. Let us find out the determinant of the second one. Okay, so let us go by this. That is, we know already. Remain taking 2 and we will take 5 minus 7, 0, 4. Taking minus 3 outside, then 1 minus 7, 6, 4. Taking 5, then 1, 5, 6, 0. Do you understand? And when you have this, you are able to get 28. Okay, so in the previous case, you again check it, you will have minus. So it means the second property is verified. Do you understand? You please work out for this one and get me the answer and check whether it is just opposite to this. Do you understand? Please go ahead, check that. Okay, let me wait for a while and report it in the Telegram. Send your JPEG to the Telegram. Let me check later, no problem. So let me go to the third property. Let us proceed with property 3 of determinant. if any two rows or columns of a determinants are identical, note this point, identical, then all corresponding elements are same. That is, the corresponding elements should be same. Then the value of determinants is 0. Okay. Now, you see, you have 3, 2, 3, 3, 2, 3. So two rows are identical. Is it not? The first row and the last row. Okay. Right. And when we expand the first row, we get 3 of 6 minus 6, etc. Do this, that is equal to 0. And since this is also equivalent to this one, when you identify this and based on that proceed, you will get the same result. So they are identical. So it means just by looking at the same or identical elements in two rows, then you can come to a conclusion that determinant will definitely give you 0. So this is a very simple thing, and it can be either in the column or row. Either you have to check the column or row. In this case, you have 3, 2, 3, 3, 2, 3. Okay, right. Now let us proceed with the next property. That is 4. In this case, each element of a row, each element of a row or a column of a determinant is multiplied by a constant k. Then its value gets multiplied by k. Okay? Do you understand? Let me explain, and before that, we'll go through the remarks given here. By this property, we can take out any common factor from any one row or any one column of a given determinant. Okay, so you can take outside like a GCD. Then, if corresponding elements of any two rows, listen to me, if corresponding elements of any two rows and columns of a determinant are proportional. Okay, proportional means that is you are multiplying by the same constant. Okay, same ratio, then its value is 0. Listen, so 0. Let us work out with an example. See, in this case, A1, A2, A3, B1, B2, B3. But when you look at the third row, it is proportional to A1, that is first row. A1 is proportional to this one. It means a k into k is a proportionality constant. Okay, for example, if it is a 2, if it is 3 means, 6 means it is multiplied by 6. So all factors, all elements are multiplied equally by 3. It means that is, it is proportional. So A1, A2, A3, okay, the row 1. Okay, the row 1. And what about this? That is KA1, KA2, KA3. So these two are proportional. Do you understand? So R1 and R3. So you can correct this as R3. They are proportional. So the result should be 0. Okay. So in a previous case we discussed when they are equal, when there are identical rows, then identical two rows, that resulted 0, and similarly here when they are proportional also it is 0. So please note down this point. This will be very useful for solving some major determinant problems. Okay. So what about the previous one? In this case, they are identical, then it becomes 0. And in this case, when they are proportional, okay, either rows or columns are proportional to each other, then you can declare that the determinant is 0. Okay, you need not work out at all, straight away based on the property. And let us verify this property. Okay, now 102, 18, 36, first row. Okay, this is first row. 1, 3, 4, second row. 17, 3, 6, third row. Okay, now 36, let us consider the last element of the first row and the last row. Okay, so 36 divided by 6, that is 6, is it not? And then, so we are considering these two rows, 18 and 3. So 18 by 3, that gives 6. So it's proportional. 102 divided by 17, it is 6 times. So that is proportional. Definitely it should give 0. Okay, so likewise we can declare. Got it? The fourth property. And we can make it as a third property also. How? By taking 6 outside the determinant. So we made these two rows identical, is it not? So that is by the third property. And this is by the fourth property. Do you understand? And that is why it is a combination of 3 and 4. Got it? Now let us move to the fifth property. Here, some or all elements of a row or column, all elements, note down this point, or column of a determinant are expressed as sum of two or more terms. Okay, two or more terms. Then the determinant can be expressed as sum of more or two terms, two determinants. Okay, now let us explain with an example. Show that A, B, C, A plus 2x, B plus 2y, C plus 2z, x, y, z, that is equal to 0. Here, let us consider the first row. This is first row, okay? Row number 1. Row number 2. What is row number 2? A plus 2x, B plus 2y, C plus 2z. Row number 3, okay? Now, what we can do? We can identify the third row because it is added with what? 2x, 2y, 2z. Okay, so that can be separated as a two different determinants. So you can write down ABC, ABC, and you can split this, the same ABC with the 2x, 2y, 2z. Are you able to follow? So I have isolated the second row only, that is second row only, into two determinants. Okay, so 2x, 2y, 2z. Okay, but keeping remaining all other elements. Okay, I have kept ABC, ABC. I have not disturbed the XYZ, XYZ. So we have done only these things. We have separated into two determinants of equal elements except these two. So this is the composition of what? Two determinant 1, determinant 2. Okay, so in that case, now you just look at it here. ABC identical element, is it not, by property 3? Okay, this becomes 0. And what about this 2xy, 2x, 2y, 2z, xy, y, z? So this is by property 4, is it not? Property 4, and this is property 3. Why? Because it is proportional, no? X, Y, Z. So you can multiply by 2x, 2y, 2z, that's all. So by that, or in terms of a P4 also, P3 also we can explain. You can take 2 outside the determinant and declare that X, Y, Z, X, Y, Z. Okay, right. So in that case also, this results 0. Do you understand? So you please just go through that. If sum all elements of a row or column determinant, they are expressed as a sum of two or more terms, sum of two or more terms, then the determinants can be expressed as a sum of two more or determinants, not only two, even 3, 4, etc. Okay, so if you have got a plus 2x plus 2, I mean 3x, means that is you can split into 3 terms also. Okay, 3 determinants. Is it clear? Right. Now let us move to The next property 6. Property 6. Check down. Here, if to each element any row or column, that is understood, it always implies, of a determinant, the equimultiples, underscore this, equimultiples of the corresponding elements of other row or column are added, then the value of determinant remains same. There is no change in that. Okay, the value of the determinant remains same if we apply the operation, that is Ri to, that is R L J, and similarly K or J, okay, R I plus K J, K into R J. Similarly, column I, that is transform into column I plus K column J. Okay, let us explain with a, that is a sample, example. Now listen, we have A plus B, A plus B plus C, 2A, 3A plus 2B, 4A plus 3B plus 2C, 3A, 6A plus 3B, 10A plus 6B plus 3C. Okay, so these are the different terms. Okay, now let us consider this is row 2A, 3A plus 2B, 4A plus 3B plus 2C. So this is second row. And the third row is here. Now what we do? Let us do this operation. That is R2 becomes R2 minus 2R1. What is R2? Let me write R2 here. This is R2. 2A and then 3A plus 2B and then 4A plus 3B plus 2C. Okay. Now 2R1. So let us write 2R1. 2A, then 2 into A plus B, that is 2A plus 2B. 2 into A plus B plus C, that is 2A plus 2B plus 2C. Now we need to subtract. So 2A minus 2A, 0. So that is this. And what about this? A plus 0, which is nothing but A here. Then 2A plus B plus 0, that is 2A plus B. Okay, so similarly you have to do the transformation here for R3. So we get 0, 3A, 7A plus 3B. You understand? Right. Now applying R3. So after converting this, applying R3, okay, to R3 minus 3R2. So where is R3? This is R3. Now this R3 is going to become R3 minus 3R2. Okay. So what is 3R2? This is 3R2. So when I subtract by 3R2, what happens here? So 0 minus 0, 0. And then 3A minus 3A. So 0. Okay. And then 3R2. So this is 6A. And this is 3B. So 7A minus 6A, that is A. 3B minus 3B, A. 0, and it results A only. Okay. Now we can expand along, that is C1 also, that is column wise. Okay. Now let me go by column wise. So I know that is it is very convenient if we take the first column. Why? Because it contains many zeros. So let us target this A. Let me consider this first column, so that I have to leave this one. Now I must multiply this. Okay, I have to take this. So this is the first one. And when I take 0, this becomes 0. 0, everything becomes 0. So I have to consider only this. So A into A plus 2A plus B, A, 0, A. So we get finally a cube, hence the proof. Okay. So with the help of these properties, we are able to solve many determinants. Okay. Yes, students, is there any doubt? If there is any doubt, we can discuss in the Telegram. If you got any specific doubt, we will discuss. Otherwise, we'll move with other sums also. Okay, let me give you some more sums. You try to do that. Take down. You just go through this sum. Let me send the sum. Please go through it. So you had to use the property of determinant without expanding. It's given here x a, x plus a, y b, y plus b, z, that is z c, then z plus c. So we had to prove by applying the properties. We know x a, x plus a, that is, let us consider the first column, second column, third column. The third column can be what? Dissociated, is it not? It can be dissociated. So as what, that is, you can retain x, y, z and split a, b, c alone and make it as two determinants. So I am arranging that I am attacking only the third column. So x plus a I am writing as x and a. So likewise I am splitting so that you are able to get two determinants. Do you understand? So x plus a is dissociated into x and a. Then y plus b is dissociated into y and b. Similarly, z plus c, that is dissociated into z and c. So that now you are able to get two determinants. Now you can find xyz in the first column, xyz in the third column of the first determinant. So it makes 0 as per the property we know, because the two columns, that is first column and the third column, are identical. And what about the second determinant, where second column and third column are identical, so that becomes 0. So by adding these two zeros, you get 0. Okay. So I believe such type of sums are very easy for you, but we will slowly move up with difficult sums also. Can you try this sum? Using the property of determinants and without expanding, you had to prove a minus b In the first row, A minus B, B minus C, and C minus A. In the second row, it's given B minus C minus A minus B. Third row, C minus A minus B, B minus C. So this entire determinant, that results 0. So we have to apply the properties. So it's a kind of dissociating, just try. Send your answer as JPEG. Let me check. Send here itself, in the group itself. Don't send privately, send it here itself. If it is correct or incorrect, don't worry about that. Do it fast. You have to consider the transformation also. How we can manipulate with the rows. Shall I give you a clue? Are you struggling? Okay, let me give you a clue. Apply R1 becomes R1 plus R2. That is the clue I want to tell you. R1 becomes R1 plus R2. So with that you can proceed. Whenever you look at the RHS as a 0, you have to just look for the properties. Okay, in which case you get 0 for the determinant. Okay, so likewise you have to proceed. And in that way you have to transform it suitably by adding the rows. So in this case, apply R1 as R1 plus R2, then proceed. And take the common factor outside the determinant. Done? Good. What about others? Either you can make it as 0 or you can make the two rows as identical. So that is also possible. Okay, so this is also possible. Right. Shall we try another sum? So in this question, you had to use the property properly. Okay. So use the property of determinant and without expanding prove that the first row is given as b plus c, q plus r, y plus z. And second row of the LHS c plus a, r plus p, z plus x. Third row a plus b, p plus q and x plus y. So you have a particular determinant on the LHS and RHS is equal to 2 into the first row APX, second row BPQ, BQY, third row CRZ. Now you have to prove that. Just try. Got that? Okay, shall I give you a clue? Right, let me discuss the clue. you please note down. You are given the LHS, that is B plus C, Q plus R, Y plus Z. In the second row, you have C plus A, R plus P, Z plus X. Third row, A plus B, P plus Q, and X plus Y. So what you do is you split this determinant into two, making or dissociating the last row. Okay, so what is the last row? You have A plus B, P plus Q, X plus Y. So retaining the other elements, you can split the third row alone. Okay, now what are the determinants you are able to get? B plus C, Q plus R, Y plus Z. The same thing, second row, C plus A, R plus Q, Z plus X. But in the third row, after splitting, what happens here? That is, we get A alone and B in the second determinant. And then Q in the first one, P in the first one, Q in the second one. Similarly, X in the first one, Y in the second one. Now you can label this as determinant 1, determinant 2. Now let us work out the determinant 1 alone, okay, where you can do some gimmicks, like that is R2, that is transformed into, you can subtract R2 minus R3. Let me post the display so that you can understand better. Okay, let me explain this. Listen. So you have got the LHS, please take down. We have got the LHS. This LHS is nothing but B plus C, Q plus R, Y plus Z. So you just don't disturb now. No need to send anything now. I am explaining. Please don't send anything now. Okay, don't send anything now. So determinant is equal to B plus C, Q plus R, Y plus Z. Then C plus A, R plus P, and Z plus X. Now look at the third row, A plus B, P plus Q, X plus Y. So by the property of the determinant, what I have done, that is I have isolated the A plus B into A and B, third row, first element. And third row, second element, P plus Q as P and Q. And the third row, third element, X plus Y as X and Y. Do you understand? And I have made this into two what? Retaining the other elements, I have made two determinants because by the property it is allowed. So determinant 1 plus determinant 2. Okay. Now let us identify determinant 1. So we have B plus C, Q plus R, Y plus S, Z, etc. Then APX. Okay. Now let us have that alone and we can apply R2 becoming R2 minus R3. Okay, R2 can be converted into R2 minus R3. Can you go ahead now? Try. In the second frame you can find, see after the transformation R2 becoming R2 minus R3, determinant 1 has become what? B plus C, Q plus R, Y plus Z, and you have now C or Z only and APX. So similarly you have to do, that is R1 minus R2. Our purpose is to convert it into an similar element like this. So BQY CRZ APX, and you can interchange, that is that interchange between the two rows like R1, R3, R2, R3 is allowed. So we have interchanged here. Okay, So after interchanging, now you have determinant 1 and taking minus 1 outside. Okay, so you have A, P, X, B, Q, Y, C or Z. Okay, so A, P, Q, now you have got A, P is the X, B, Q, Y, C or Z only. So similarly, we have to do the determinant 2 also. Okay, so you please note down first. And finally, that is you have got determinant 2. So here also you have, see, I have just interchanged. Now R2 becomes R2 minus R1. So that I am able to get determinant 2 as a C or APX, BQY, etc. Now I am interchanging R1 and R2. Okay, and taking minus 1 the whole square. Now I get APXBQY for the second determinant. Okay, so from this now we can combine so that we are able to get identical elements of these two determinants. So it can be multiplied and hence the proof of LHS to RHS. Okay, so you please go through this sum patiently, work out. If you don't understand, you can ask me in the next class. Okay, so let us have dinner break now. Have you noted down? Okay, so what you do is you have to, I believe you can now proceed with the second exercise of your textbook. Can you? So go through this and you can also replay this video whenever you want. Pause, take down the notes and once again go through the lecture notes so that it would be comfortable for you to understand in a better way. So just by comprehending or understanding the properties, you cannot get the expertise. You have to work out lot of problems, variety of problems. Okay, so with that we are concluding this session of properties of determinants. Thank you. Let us have dinner break. After half an hour we'll meet once again. Okay, bye.